In this lecture, I want to continue looking at the area of navigation and routing. We'll look at some of the other samples that we didn't cover in the previous lecture. And also, I want to start looking at the area of design, although in this lecture, we look at design at the kind of module level rather than at the app level. The next lecture will focus on app level design issues. So the title, Design Patterns, is not specific to web apps. It's actually an aspect of software engineering in general. And just by definition, what a design pattern is, and it's specified there at the bottom of the screen. A design pattern, I'm saying, is an abstracted, repeatable solution to a commonly occurring problem in software design. So kind of what has happened really over the decades is that as software engineers, we have been coming across similar types of problems that we want to implement solutions to. I'm talking about problems now at the micro level rather than at the macro level. And over time, the design of these solutions are good quality designs to these problems have kind of emerged, and they've been cataloged and documented for the rest of the community to use them, really. In fact, the text, the image there that you see on the left is the cover of a text that was published way back in 1994. So, you know, as a topic, it has been around for many, many decades. Now, I want to relate it to web apps, and specifically to web apps developed using the React framework. You can see there from the book title, it relates more to the world of object-oriented development, so languages like Java, C++. But even the design patterns that were documented in this text, they can be actually applied to areas of web development as well, as it turns out. So anyway, this is what design patterns are. They are well-founded, abstracted solutions, design solutions to commonly occurring problems in the area of software development. Now, in relation to software design, reusability and separation of concerns, I'm sure you've heard of these before. These are kind of high-level design objectives that we have. By reusability, what we're trying to get at there is the ability to implement modules or units. Units now in the context of a React app would be a component. A unit in the context of object-oriented Java development might be a class. We're looking to develop units that are reusable either within an application or across applications. By separation of concerns, we mean we'd like each unit to really just have one single responsibility. And why is that a good idea? Well, it's probably easier. It's more directed at maintainability and understandability. If each of the units within our overall application has a single responsibility, and provided it's well named, then it's easy for other people to understand our code. And also, it's probably easier to maintain our code. So we'd like to achieve these. They're kind of interrelated, the two objectives, and they are a design objective. Related to this is the notion of the DRY principle, where DRY stands for don't repeat yourself. The idea being that nowhere within your code base for a particular application should you have code that is repeated multiple times, albeit there may be slight differences between the repetitions, but it's obviously not a good idea. What we would obviously do in that kind of situation is to abstract the repeating code, put it into a unit of its own, and reuse it wherever it needs to be used. So dryness, reusability, separation of concerns, single responsibility, these are all objectives or principles of good software design, whether it be web app development or any other type of software development. Now, in order to try and achieve these there are, in general anyway, two kind of approaches that you might take to modeling your problem domain, as we say. So whatever you're trying to develop an application for, that's what we're calling the problem domain. And we're analyzing the problem domain and we're trying to come up with some sort of overall high-level design for it. Then when you're analyzing the problem domain, you can either view it through the prism of inheritance or through the prism of composition. What I mean by that is, with inheritance, you're looking for is-a type relationships in your problem domain. So for example, a car is an automobile. So if I was developing an application and car and automobile would be concepts in the problem domain, then if I was using an inheritance approach, and let's supposing I was using a language like Java, then I would have a class of type automobile and I would have a class of type car, where car would inherit from the automobile class. That's your typical inheritance type relationship. An alternative way of viewing your problem domain is to use a composition approach. Now, this is probably going to be less familiar to you. You are certainly familiar with inheritance, but in a composition approach, what you're looking for is often referred to as has-a type relationships. And to stick with our case kind of study, if you like, we might say that a car has an engine. And so we would model that. We would maybe have a car class, but one of its properties would be an object of type engine. So it's just two kind of different ways of looking at the world and modeling the world. That's what we're trying to get at here. And they're equally valid. But as it turns out, the React framework veers towards the composition model, which is really where I want to take this discussion. And it's also going to be something new for you. Now, in that vein, taking a composition approach towards modeling a problem domain and trying to achieve greater reusability, better separation of concerns, improved dryness in your code base, then the patterns, there are three patterns that have emerged in the React world over the years, and I'm listing them there. And I just want to look at each of them and show you examples of code using each of them. And we will also use, well, we'll use the first two in the Movies app. We don't get an opportunity to use number 3, but you may see an opportunity to use the third one in your own assignment, maybe later on, although that's not necessarily a high-level requirement that I have. So these are three patterns, three design patterns based on the composition modeling approach that we would like to use in our React code base. Before I talk about the three patterns, just to get a term out of the way, HTML, as it turns out, actually, HTML, if you could, it's a language in a sense, but it is based on the kind of composition approach. And the two little code excerpts that I'm showing you there, then the way we might express it is to say that if we take the one on the left, we would say that a div is composed of a H2 and a UL, or at least this particular div is, whereas on the right, I have a div that is composed of a paragraph and an image and a hyperlink. So HTML actually allows us to compose elements in any way that we want to. If we go back to the excerpt on the left, then we would also say that the div has two children, H2 and a UL, and on the right, our div has 3 children. So it's this term children that I'm just introducing here, because that actually comes into play when we start looking at React components and composing React components with other components. So the first pattern we will look at is the container pattern. Now, I'm saying here that a React component has a special prop called the children's prop. It has been there all the time, but we haven't used it up to now. And what it allows us to do is to pass components to other components. And we do that by nesting it within the JSX. So if you see my simple picture component here, in the middle of its JSX, I'm referring to the children prop. So how does this get its value? Where does it get its value from? But whatever it evaluates to, it's obviously going to be inserted into the middle of this JSX of picture. And on the right, I'm showing you in general how you control the children prop. So whatever you put here is going to be bound to the children prop of picture. And you can see the way that I'm using picture here. I have its open tag and its closing tag. This is very HTML-like, and that's what's nice about React components. We can follow the same type of syntax as we do with ordinary HTML tags. So whatever goes in here gets essentially bound to this expression here, and so will be displayed here. And so that what this effectively allows us to do is to decouple the picture from what it includes in its output to the screen. And hence we can reuse picture in many different scenarios. So it's this idea of decoupling is one of the outcomes. And so if we take a couple of illustrations, what it now means is that if I take this example here, where I'm using picture, but in this case, I am telling it I want to include a button with the picture. So the image is going to be displayed and the button is going to be displayed. The image is coming from the picture component itself. If I go back to the previous slide, the picture displayed an image. Okay, we passed it what the URL of the image was. We didn't worry about that. But what it displays after the image is up to what we're calling the consumer. The consumer is the component that's using the picture. So for this example, it's going to display a button. Whereas here, I'm getting it to display a list with the image. Here, I'm getting it to display whatever my complex component is with the image. So I'm reusing the picture for different use cases. And that was one of my objectives, this idea of reusability. Another way I could describe what's going on here is to say that my picture is being composed, my picture component is being composed with other elements or components. So that's the kind of classic example of composition going on. The next pattern is the render props pattern. And okay, the statement that the objective of the pattern is to share logic between components. I guess that would be true really of all of the patterns that I'm going to show you in this lecture. It was true of the container pattern that we've just looked at. And it's also true of the render props pattern. They all kind of have the same objective. Indeed, most patterns have this objective of reusability, but you would use certain patterns in certain situations, or maybe you could only use certain patterns in certain situations in order to achieve that reusability objective. So for the render prop pattern, first of all, we need to explain what a render prop is. And I'm saying a render prop it's a prop that is a function, but when that function is invoked, what it returns is a component or JSX, and so it's going to be display whatever that JSX specifies. So a render prop is a function prop that a component uses to know what to render. So you would pass a render prop to a component, and the receiving component would then invoke that render prop because it is a function, and the function is going to return some JSX, and so it's just going to display that JSX. So it's the same idea really, in a sense, of passing components to other components, except this time we're doing it via a traditional prop rather than the built-in children prop. Again, a 101 example. So you can see here in the middle of my component, I am going props.render, but this time I'm using render as a function because I said that at the top that the render prop is a function. So I'm invoking the function. So whatever this expression evaluates to, in other words, whatever the render function returns, which will be a component or some JSX, that's going to be inserted into this overall JSX of what I'm calling my shared component. Here's an example of it being used, and again, it's a 101 kind of example. So I'm using my shared component, and I'm passing it the render prop explicitly, and it is a function that's being assigned to the render prop. It's an arrow function, it's a one-liner, so I don't need the curly braces or the return statement. So this function here returns, it looks like a span, which means if we kind of looked at the runtime outcome of this overall piece of code here, it would look like that. So the div and the on mouse click handler, all of that is coming from up here. The span is coming from the render prop and the closing div. So again, so the shared component receives its render logic, that being just the span in this case, it's pretty trivial. It receives its render logic from the consumer. The consumer, again, is the component that's actually using my shared component. That's the terminology that we use. Here's a better illustration of the render prop, or a more real-life illustration of it. So I'm going back to my friends list app that we had from the previous lecture. And whether these are two different pages on the same app or two different apps, either way, it looks like that for the one on the left, I want my friend component to, or my list of friends to include the friend's name and an image. That's how I want them rendered. Whereas on the right, I want the friends to be displayed as their name and their email address. So there's clearly an opportunity to have some reusable components between those two pages. Now, we know from the previous lecture that this was the design that I gave you in the previous lecture. But the problem with the design is this relationship here is actually hard-coded, which means that this component, the only way it's going to work is by rendering friends as they are encoded in this particular component. Whereas on the previous slide, I have two different ways of rendering a friend, but I'd still like to be able to reuse this component, because what it does is going to be the same between my two applications on the previous slide. It's going to map over an array of friends and produce the output, but the output that it produces is going to be different. So this kind of hard coding or hardwiring or static relationship isn't going to work for me. I'm still going to be passing my friends, my array of friends, down into this component, and this is the one actually that's going to be changing now as a result. But as well as passing the array of friends, what we'll see is that I'm going to pass down an additional prop, which is going to be my render prop. And that prop is going to enable my filtered friends list to display my friends in the way that I want them to be displayed, whether that be their name with an image or their name and their email address. So this design isn't going to work. And so I'm telling you on the right what the solution is. The solution would be to pass not only the list of matching friends, but also pass down as a prop a way of communicating to my filtered friends list how it should display each friend. And I'm going to do that using the render prop pattern. So here are some excerpts from the app itself. The one in the middle is showing you the component that is receiving the render prop, and the excerpt on top, and the one at the bottom is showing you two examples of using the component that is past the render prop. So if we take this one, so we're passing our component the list of friends, and via the render prop, we're telling it how it should render each of my friends. So this component, as we'll see in a while, this is the one that generates the friend's name followed by their image. Whereas down here, I'm using the exact same component, but this time the render prop is telling it to render the friend in a different way. This component, as we'll see, is the one that displays a friend's name followed by their email address. And here I have within the shared component, this is the shared component in this case, because it's being used here and it's being used here. I'm just simply invoking, I'm mapping over my friends as before, but for each element that's mapped over, I am invoking the render function that has been passed into me. In other words, this function here. I'm invoking that, and I do need to pass the friend that's currently being processed because it's being actually used here. So that means that this variable here, friends, it's going to be an array of components, and what type of components it is going to be depends on what this function invocation returns. So in the case of this use of it up here, my friends array is going to be an array of components of this type. Whereas when I'm using it down here, the friends array is going to be an array of components of this type. So the filtered friend list saying is no longer statically imported. If you look back at the filtered friends list component that I gave you last week or in the previous lecture, I actually had an import statement here where I statically imported the friend component. And so I was bound to rendering my friend in a particular way. Whereas now I'm being told by the consumer, this is my consumer up here and down here, I'm being told by the consumers how to render the friend. So I no longer have a static import of the friend. It's received via the friend's prop or the render prop instead. And yeah, so what I'm saying here is that if I didn't have the render prop pattern, then that would mean I would need to have two instances of this component. One which renders the friends in one way and the other one which renders the friend in the other way. And they would be statically importing the particular friend component code. So I'm reusing this in two different scenarios in my case. And the last point down here is, I think I've mentioned in passing, the name of the prop isn't really significant. It's just by convention, it's referred to as the render prop, essentially because it's telling the shared component what it should render on its behalf. Now, to get the full app, as I said, just grab the archive. So you get something like this here. Now I'm using this project for another example as well later on. So some of the components don't relate to what I'm talking about at the moment, but if I expand the source folder, and app is, if you remember, my component at the very top of the hierarchy that has all of the state associated with it. So we've seen all that from before. There's nothing new there. So what is new is the way I'm using the filtered friends list, which we've already seen. And at the very top, I've got a couple of imports that I'm just going to swap in and out rather than having multiple applications. So at the moment, I'm importing friend contact, and friend contact is this one here. And that's nothing new really. We've seen that before. And I guess if I just run it, so it looks the exact same as before. But the beauty of the way that I have redesigned it, and in particular, I've redesigned the filtered friends list, the benefit comes as follows. If I go back to my app.js and I comment that out and bring in this one. And now down here, I change this to save it. And now my friends are being rendered in a different way. The third pattern is the higher order component. And what is a higher order component? I'm saying it's a function, number one, and it's a function that takes a component as an argument and returns an enhanced version of that component. I've mentioned this before to you. Actually, we've seen an example of a higher order component function. But in general, when I talk about enhancing, giving it a component and the function returns an enhanced version of it, by enhancements, we mean it may make the component that you pass to it a stateful component. It may receive a stateless one and make it stateful, or it may receive a stateful one and enhance its statefulness, or it may pass or provide extra props to the component that you supply it with, or it may enhance the component's UI. So these are all possibilities. It doesn't have to be one of three. It could be a mixture of them. And what we have seen an instance of it already, which was the with router function, if you remember. And what the with router function does is it provides extra props to your component, props related to routing. In that instance, there is a convention as well, a naming convention associated with higher order component functions, which is that they all prefix, their name is prefixed with, as in they are providing your component with some additional functionality. So what I decided to do was to stick with the same Friends app, but in this case, what I want to do is I want to add a click handler to multiple components. Now, in my case, the components are the friend components, but it could be any component. Make it clickable. What the component does as a result of it being clicked, that's up to the component itself. But the clickability is something that we can abstract into a higher order component function, as we'll see. Now, what I decided to do was I decided that I wanted my friends to be clickable. And in the case of a friend that's being rendered this way, when you click on it, a button appears that presumably would allow you to carry out some action, which I haven't gone into, it's not important. If you clicked on that friend again, the button would disappear. So that's the effect of the clicking. In this case, on the right, clicking on a friend caused the friend to have a border drawn around it. So it's kind of a way of selecting, I guess. And we are going to use a higher order component function to achieve this, because the functionality of making it clickable is the same in both cases, and therefore it can be abstracted into a reusable unit, albeit the unit in this case is a function rather than a component. So let's look at the application working first before we look at the detail of the code. So it's the exact same project that I'm using now. I'll just import or enable the relevant imports. Save that change. And now simply by clicking on friends, my button appears. If I click again, disappears, and so on. That's illustration number one. And the second illustration, save that. This time clicking has the effect of just putting a border around the friend. Okay, so the nature of what I'm doing is the same in both cases. I'm making the friend clickable, or the component clickable. The component has to be, just happens to be both of type friend, I suppose, in this case, but it's the clickability that's common between both applications. How the component reacts to the clicking is different, and so that logic will be within the component itself. But the clicking feature can be coded separately and applied to both of them. And we're doing that by using the higher order component pattern. What I'm showing you here first, before we look at the detail for our particular application, is the more kind of general solution of how you implement a higher order component function. And it does kind of look unusual initially. But so first of all, a higher order component is a function. So that's seems like what I'm doing here. I am indeed assigning a function to my variable. So this is going to be the name of my higher order component function. What it's passed is your custom component, and it needs to return an enhanced version of your component. Now, of course, we know components are implemented as functions, so that seems to be what's happening here. I'm returning a function, and the function that is being returned, as part of its return statement, it includes the component that was passed into my higher order function. Now it's not doing any enhancements in this case, but that's okay. But the component that is being returned, which is this entire thing here, that component includes within its JSX, it includes the component that I passed to my function, my higher order component function. And of course, any props that I specify for my component, those props need to be passed on here. And that's really what's going on between here and here. You could kind of take it as a boilerplate without going into the specifics of the syntax. We know, for example, this is the spread operator. So props here, this object is going to be instantiated by the runtime from your component that you've passed in to the invocation of the higher order function. So we need to take that props object, we need to take the individual elements of it, spread them out, and put them into a new object, which is what I'm doing by virtue of those curly braces there. I'm putting them into a new object, and this entire object, I am using it over here, and in a sense, I am undoing what I did on the left, in that I'm spreading out the individual elements of that prop object as key value pairs to make them available to this component here. So it does look a little bit unusual, admittedly, and maybe, not sure if it's the first time that you've implemented a function that returns a function, albeit in this case, the function that's being returned is a React component, because all of this is coded within the context of React. Maybe if we look at the tangible example, it might make it a little bit easier. Here is my higher order component implementation. And the purpose of my higher order component is to take a custom component of mine and to make it clickable. And the clickability is going to mean adding state to my custom component. And so here I am, I'm declaring a state variable in the usual way. I'm declaring an event handler for when the user clicks on my custom component, and I'm changing my state variable. So the first time they would click it, it's being initialized to false, and the first time they would click it, it would go to true. The next time they would click it, it would go to false. So I'm just turning it on and off if you like. And in the return, so this is what is being, this is the enhanced component that's being returned. And the enhancement is not only the addition of this state variable and the click handler, but I'm also wrapping my custom component in a div, and I'm using the, I'm coding the onClick event around the component that was passed in to me. And here we go again. I'm taking the props that was created for my component. I'm taking them and I'm passing them on to what is being returned by this function, but I'm also adding on a new prop. So my higher order component function is not only adding state to my custom component, it's actually also adding on an additional prop, or providing an additional prop to my custom component. So the higher order enhancements of my custom component is, as I said, it's adding state and it's also adding an additional prop to it. Now, in terms of using this function, so I'm exporting it, and in terms of using it, then here's an illustration of it being used. Here I have my custom component, and down at the very bottom, I'm passing my custom component to my higher order component function. And so that means that by doing that, that allows me, for example, to refer to props that clicked within my component, because the clicked prop, as we saw on the previous slide, is an additional prop that my higher order component function provides to my custom component. Now, all I'm doing in this case is I'm checking to see, is that expression true or false? And I am deciding what CSS class, this is a CSS class that I've defined in my CSS file. And I'm applying that class to my LI element, as you can see there. That's all that's happening. So this is the example where I drew a border around my friend. Here's me invoking the component that is the component that's being returned by my higher order function. That's the component that I'm using down here. Now I'm happen to be using it with the render prop pattern, just as a natural flow from what we've looked at already, but it's not dependent on the render prop pattern. We're discussing the higher order component pattern here now, but I happen to be using it with the render prop as well. But this component here, this is equivalent to what is returned by my higher order component function. And notice here, I'm not actually specifying a clicked property, because the clicked property was actually injected by my function, as in the clicked property was being provided here. I do not provide it in my own kind of custom code. So the click prop does not appear, as I said, in the invocation of the custom component. That's actually provided by the higher order component function. The second point that I'm making here is specific to this use case, though, which is that it's up to the custom component to decide how it should react to the clicking. In this case here, I'm deciding to influence the CSS style that's being applied. But in the other case, I decided to add a button, as you note. So maybe if I looked at the other use of my higher order component function from the actual code. So here we have another friend implementation, and again, I'm using my higher order component function. And within my code, I am referring to props.clicked. But in this case, I'm just using it to either include a button or include nothing, essentially. By the way, this is a technique that you will see me using a couple of times. You can have an expression buried within your JSX where you evaluate something, and depending on whether it's true or false, you decide what should be included in the overall JSX. Again, that's just a little technique that we use quite a lot. So our JSX is somehow part of what it generates is based on a condition test. So both the render prop and the higher order component, they are quite tricky to follow them. Examples hopefully will make it a little bit easier. So you will need to study the code in a bit of detail. And I use the render prop pattern in my movies app. I don't use the higher order component one. So I would advise you maybe to study the sample app first so that you're comfortable with how you implement both of these patterns. And then when you get to see it being used in the larger app, the Movies Fan app, then hopefully it'll be easier for you to understand how it works. So the objective here is to try and produce more reusable units, whether that be reusable within your application code base or across multiple applications. And also to try and achieve units that only have one responsibility, so that the various concerns that make up your application, they're well separated out into individual components. That makes it easier for us to understand and others to understand our code base. And also we want to try and obviously eliminate any repeating code across our code base within our application. They're the objectives, and the benefits of this are you finish up with a more maintainable code base. At some stage, bugs will arise and they have to be debugged and removed from the code base, and that's going to be a lot easier to achieve if your code base is well structured. And that will be achieved by ensuring that the components or your units are reusable, good separation of concerns, etc., etc. Understandability is another benefit of all of this. Other people will be studying your code base, be that within your project team. Thirdly, their extensibility. Hopefully, you will be adding more functionality at a later stage onto an application, and that's going to be easier if your code base is already well structured. Adaptability is kind of similar. Although it might be adapting components that were developed for one application, but actually applying them in a different application context. So all of these are the benefits or rewards for aiming for the objectives that I mentioned at the top. And arguably the approach towards approaching these objectives or achieving these objectives is to apply design patterns to your code base. Of course, you have to choose the right patterns as well. That's another day's story, but relating all this then back to React, React follows a composition programming model. That's just a consequence of the fact that we're using JavaScript and the fact that they adopted this component model. But in terms of patterns, then there are patterns have emerged over the years that are proven to be useful in achieving the objectives that I've talked about. Now, there is one other pattern that we will look at in a later lecture. I want to now go back to the area of navigation and look at the remaining or some of the remaining samples that we started to discuss in the previous lecture. So it kind of emerged over the years that the general layout of any web application tends to follow what you're seeing on the screen here, in the sense that there tends to be a static part which remains constant as you navigate from page to page, and then there's a dynamic part which always changes as you navigate from page to page. Now, I'm kind of overdoing it on this slide, but in most cases anyway, web applications would have a static header and a static footer that remain constant or persistent across all your pages. They may have a side menu. And then in general, kind of this area within the page tends to be the part that changes as you navigate around the place. So how do we achieve these kind of static aspects in React? React calls them persistent elements or persistent components, as in they persist across all pages. And of course, what we're really talking about here in terms of use cases for these persistent elements are site-wide headers and footers, site menus. So relating this to our little case study or glorified email client, let's say we want all of the pages, the home page, the about page, the inbox page, all to have the same header and the same footer. And that's going to be constant across all our pages. And it turns out it's actually quite easy to achieve that. What you see here is the component that has the main routing configuration. And so all you've got to do is insert the persistent components within the routing configuration. That's actually permitted. We don't have to have all routing related components in here. We can have custom components as well. So we'd stick in our header and our footer and whatever. If there was a side menu, we'd have probably a component for that as well with the appropriate styling so that it shifted to the left or right of the screen, whatever you wanted. And then really in the two components that I've highlighted there, that's where you put your JSX to achieve the header and footer that you desire. So I've done it in sample 6 in the routing samples. So if we go over to VS Code, now you have these samples, as I said, from the previous lecture. So we're now interested in this one here. I have my server up and running. And if I switch over to sample 6, so here we go. If I navigate around, then they remain constant. And really, I've shown you the key coding part that achieves that. But if we look at the index.js for sample 6, so here, well, sorry, here are my components. Obviously, this is the component that implements the footer. This is the one that implements the constant header. Now, I've used the Bootstrap CSS library for the styling of my header and footer. In the labs, I'll use Material UI. So that's the fact that I'm using Bootstrap here is not really significant as such. But in the index.js, so we've already seen, anyway, in the component that has a main routing configuration, we're referring to header and footer. And those components are just, they're fairly standard components, really. So you can browse through that in your own time. Now we've seen the root component already. That's the component that we use to facilitate matching the browser's URL to a component being mounted, although really it's kind of matching a URL to a new page appearing on the screen. This is how we code it. The problem with this particular form of the root, though, is if we want to pass custom props to the component that's going to be mounted, we have no way of achieving that using this particular version of the root component. So for that reason, the React router allows us or gives us an alternative form of the root component, which looks like this. And now, as you can see, the root component takes the path prop as before, but instead of the component prop, we pass it a prop called render. And lo and behold, this is actually the render props pattern being used here by the React Router library. But let's pretend that we didn't know anything about that. The render prop for the root, you pass it a function. Now the function can have any logic it wants to in there, but critically the function needs to return the component that you want mounted. In other words, it needs to return whatever component you would have specified up here. But presumably inside in the function, that's where you might initialize the additional props that you want to make available to the component, and you can pass those props to the component in the way that we normally do. So as an illustration, now unfortunately it's sample 7, but it's kind of linked back to sample 4, which admittedly was a week ago for E now, but let's try and work our way through it anyway. If we look at the isolated parts of the implementation, then that might be sufficient to get the explanation across to you. So what I have essentially is I have this root entry, and the component, the path is whatever, path is this, and the component that I want mounted is the stats component. You may remember this root entry was actually a nested root that I had inside my inbox, but it doesn't have to be a nested root. It could be a root at the top level of your configuration. Now, let's supposing I've done some adaptation of my application, and I want to pass some additional custom props down to the stats component. So I need to change how I've implemented this route. So here's my rewrite or my update to my route implementation. So the path is the same, but now I'm using the render prop, and as required, I'm passing it a function. The function is returning the component that I want mounted, and over here then is where, in my case, I have the custom prop that I want to pass to my stats component. I've hard-coded it, which is obviously not what would happen in real life. This array might be computed somewhere else in my code base. So there's my custom prop. These are just the default props that would be available to any component. Now this is implemented in sample 7, I think. Sample 7. And if we just maybe step through the code a little bit for this one now. So here's my top level routing. The one we're interested in is this one here. It's going to mount my inbox component. Nothing new there. And if I look in my inbox implementation, this is where I'm using the alternative form of the root, as you can see here. And I'm asking it to mount the stats component with this specific custom prop. And down in my stats component, there's nothing unusual going on there, really. I mean, it's just accessing the prop in the normal way. The only other thing that might need to be explained is what's going on here, although we've seen something similar to this in the higher order component implementation, if you remember. But the way I'll explain it is this component is going to receive a props object. Some of the props might be custom ones, some of them might be props provided by the React router. Either way, it's a props object, and I want to pass that props object and make it available to my stats component. I may or I may not want to do that. In this case, I definitely do want to do that. So that's what's going on here. The props that are passed into my wrapping component, my wrapper component, if you like, that props object is going to be an argument to my render function if I need it. And in this case, I do need it. I'm actually taking the props object, I'm spreading out its entries into key value pairs. So any props that were available to this component are now going to be available to this component. And in particular, I want to have access to the props.match.params.userid. I want to have access to that down in my stats component. Now I'm only just displaying it, but you may actually in real life use that to make an API call, for example. So this expression here is going to fail if I do not pass the props down to my stats component in the way that I'm doing here. And maybe I can improve that if I go to see how this is rendering on the screen. So if I just click this hyperlink, so the inbox component is generating this, my stats component is generating this. And to kind of prove it, in my stats component, I'm accessing the user ID 1234, which is part of the URL, as you can see up here. Now, if I, and that's that 1234 is generated from this expression here. I'm sorry, from this expression here. But if I get rid of this, and save it, I now get an error, and it's telling me that props.params is undefined, which indeed it is. So I'll undo that. So I think really what we tend to do is we tend to pass the props down to the subordinate component as a kind of a default, irrespective of whether we need to use it or not. It's just good practice, I suppose. Let's put it that way. But it's definitely necessary in this case. That's the alternative form of the root. And sorry, just to, you can use that alternative form in your top level routing as well. Here I'm using it in a nested route, but you can use it in the top level routing if you so wish. And I think I do that in the lab. That's the alternative route. So you can read through that slide yourself. The next sample illustrates what I'm calling programmatic navigation. To date, the only way we can navigate around our app is through hyperlinks. But sometimes you may want to express navigation within your JavaScript code or to achieve it within your JavaScript code. So there may be some decision logic. If something is true, go to one page, otherwise go to another page. So how would we express that in our code base? And the answer is we use programmatic navigation. And how does React support that? And it turns out there are two ways we can implement it. And it's kind of a matter of choice really as to which you pick. Sometimes you may have to take one approach rather than the other, but there's a declarative way of implementing it and an imperative way of implementing it. And I've given you examples of both of them so that you can see the structure of your code. And the classic kind of use case for this is where you've got, let's say, a registration button on your app header. User clicks on the registration button. That brings them to the registration form. They fill out the form and then they click the register button. Now, behind the scenes, when they click the register button, let's say there's some bit of code, the event handler deals with the registration details that have been entered, validates them, sends them back to an API, etc., etc. And if everything is okay, eventually then the app will redirect the user, let's say, back to the home page. So it's this redirection that we need to implement programmatically within our JavaScript code. In this case, it would be within the event handler that is triggered when the user clicks the register button. So sample 8 is demonstrating this. Now I have two, as you can see here, I have two registration hyperlinks. One of them implements the redirection, the programmatic navigation in a declarative style. The other one implements it in an imperative style. So let's look at sample 8. And so the behavior is click on your registration, fill out your form, Maria. We're not interested in the form filling. Click your register, and you're back to the home page. And this one works the exact same way. So let's step through the code. So I have two routes for the two hyperlinks, even though they both achieve the same thing. And here are my hyperlinks in the home page. So let's suppose the user clicks on this hyperlink. The URL changes to /register D, as in D for declarative. The component that's mounted as a result of that is, so this is the route that applies. It mounts this component, which is declared in another file. So this is the component now that displays my registration form and the registration button. When the user clicks on the button, I run my local event handler. And the event handler carries out a state change. So I've declared a state variable, and really the only purpose of this state variable is to facilitate the programmatic navigation. If I go back to the slides, I said there are two approaches to implementing programmatic navigation, declarative and imperative. If you take the declarative approach, which is what we're looking at now, in order to implement your programmatic navigation, you need to define a state variable specifically for this purpose, for the programmatic navigation, and you use the redirect component to achieve the redirection, or to achieve the navigation for you. So here we go. In our case, once we change the state variable, initially the state variable is set to false. So that means that the first time this component is mounted, my home is going to be false. And if we follow the logic, I've got a simple conditional statement here which checks to see is it true. So clearly that expression is going to evaluate to false, so it's going to skip over that, and it's going to render my registration form. Eventually the user clicks this button. That triggers my event handler. The event handler changes my state variable. So now this has a value of true. Of course, when we do a state change, my component re-renders. And on this re-rendering, this expression is going to be true, which means it executes this line. And the effect of this line is to cause the browser's URL to change to / and whenever the browser's URL is changed, my routing configuration kicks in. The routing configuration in this case says that, as always, really, says that if the URL is / then mount the home page. So I've achieved my redirection by using a combination of a state variable and the redirect component provided by React Router. That's the declarative way of implementing programmatic navigation. The imperative way, I'm going to illustrate with this hyperlink here. So if the user clicks this hyperlink, then the component that's mounted is, according to my routing configuration, is this one. And I need to look at this component. This component now also displays my registration form with the registration button. So the first time this component mounts, this is just an ordinary declaration, and it displays my registration form. Eventually the user clicks the button. That triggers my event handler, and my event handler executes this. Now, where did the history prop come from? The history prop is an additional prop that is available to my component as a result of me using the with router higher order component function, which we've seen before. So this higher order function also provides a special prop called history, and history, that is an object that has a method called push. And what that method does is it pushes this string onto the browser's URL address. In other words, it changes the browser's URL address. And we're back to the usual story of when the browser's URL address changes, then the routing configuration kicks in and makes a routing decision for us. So this is an imperative approach towards implementing programmatic navigation. And again, you can go back and study that yourselves. I use programmatic navigation, and I think it's mainly the imperative approach that I use in the Movies app. Now, there is one other sample that I need to look at, but I'll leave that go until a later lecture. But we've seen the essential aspects of the React Router library at this stage. It follows a declarative program model. You might remember I said to you that the React Router library is maintained by a completely separate community. It's not part of the Facebook's suite of React libraries. But it does follow a declarative programming model in the sense that it provides us with components which can be composed. It uses composition in its programming model, and it does follow the essential React flow. Browser event might cause a state change, and once a state change happens, then re-rendering occurs. So that's happening really behind the scenes with our root component, etc., etc. These are some of the components that the React Router library provides us with. I think they're the ones that you will use 99% of the time. We've seen the with router higher order function. Now it turns out that more recently, I'm saying down here at the bottom, more recently the React Router library provides us with hooks. And essentially the hooks are an alternative to using the with router higher order component. And I'm mentioning some of the hooks here. I don't use it in the labs, but you can Google it yourselves if you want to. Some people don't like this with router approach towards achieving the various features that it provides to us. Finally, I want to talk about custom hooks, essentially hooks that we write in our own custom code. So not only does the React library provide hooks to us, third-party libraries like Material UI and another library that we will use later on in the Movies app, they also adopted this hooks programming model. So it's had quite an influence, even though it's only been introduced since 2019 by the React team. And why would we write custom hooks? Well, it's the reason that I've been talking about a lot at the earlier part of this lecture. It's to achieve reusability of some code that we've written. Typically, where a custom hook might come in is if we've got a component that has some state manipulation code, and that code is repeated, let's say, in other components, then that's a classic opportunity to implement a custom hook. So if we take this example here, which looks like it might be from a library management web app, then we've got a component that is retrieving a book object from a web API and storing it in a state variable. And let's suppose that this logic is actually appearing in other components as well, because presumably there may be other pages within our web app that displays book-related information. So what we would do is we would take the code that I have wrapped in the box and simply put it into a function of its own. And now we've got our own custom hook because the body of this function contains React state manipulation code. And so it's not just any old function. We would refer to it as a hook function, even though it's implemented as a plain old JavaScript function. But because it is a hook, then I've prefixed its name with the use prefix, because this function can only be invoked at the high level, at the top level within a component. So it has the same restrictions as all hooks do. But other than that, it's a plain old function implementation. And in terms of using this hook function, this custom hook, well, it looks like what you're seeing on the right. Now, hooks, the parameter for my hook function, that's up to you to decide, but it would make sense that ISBN number would be a sensible parameter for my particular custom hook. What the hook returns, in general, hooks tend to return a collection data structure, whether that be an array or an object. And it's really up to you to decide which you want to use. I think so far, any of the hooks that we've looked at return an array, but later on we'll see hooks that return objects. And what entries you put into that collection data structure, it's really up to you to decide what would be useful to whatever component is using your hook. Now it makes sense in this case, I guess, that I would return the book object and a function that allows the user to request another book, i.e. the setter method. So my custom hook, as I'm saying, is an ordinary function, but it can only be invoked from the top level of a React component. prefix its name with use so that the linters that come with the Create React app check to make sure that I'm using this custom hook properly, or that other people use it properly. And it returns, all hooks tend to return a collection data structure, as I said, because if the nature of what a hook does is state management, then we need to have access to the current value of the state, and we need to be able to change the state. And so hence, I'm returning, in my case anyway, the set book setter method as well as the book instance. There's an interesting website that I came across recently called the Use Hooks website, and it has some really nice custom hook implementations contributed by various developers across the open source community. And you might find a hook in there that you can use in your assignment, maybe not, but it's worth browsing through them anyway. There's a whole list of hooks that have been developed, as I said, by the open source community. There's quite a number of them, because if you scroll down to the bottom, there is a number of pages that you can flick through. And there are some nice hooks in there, as I said. We will implement one custom hook in our Movies app, but that's really only for illustration purposes. I could have done some more custom hook implementations, but just to give you one example, I think we're sufficient.